Hello, and welcome to the next section, Beginning Data Analysis. In this section, we will see how to develop a data analysis routine, reduce memory by changing data types, and select the smallest of the largest. Then we will learn to select the largest of each group by sorting, replicate n largest with sort values. This section begins by covering the tasks you might want to undertake when first encountering a new dataset. The section proceeds by answering common questions that are not that trivial to do in Pandas. Let's begin with the first video of the section that will get you started. Developing a data analysis routine. This video covers a small but fundamental part of EDA, the collection of metadata and univariate descriptive statistics in a routine and systematic way. It outlines a common set of tasks that can be undertaken when first importing any dataset as a Pandas data frame. This video may help form the basis of the routine that you can implement when first examining a dataset. Although there is no standard approach when beginning a data analysis, it is typically a good idea to develop a routine for yourself when first examining a dataset. Similar to common routines that we have for waking up, showering, going to work, eating, and so on, beginning a data analysis routine helps one quickly get acquainted with a new dataset. This routine can manifest itself as a dynamic checklist of tasks that evolves as your familiarity with Pandas and data analysis expands. Exploratory data analysis, or EDA, is a term used to encompass the entire process of analyzing data without the formal use of statistical testing procedures. Much of EDA evolves visually, displaying different relationships among the data to detect interesting patterns and develop hypotheses. Now let's get started by first collecting some metadata on the college dataset, followed by basic summary statistics of each column. To do that, we read in the dataset and view the first 5 rows with the head method. We can now view all the columns for the first 5 rows. Next, get the dimensions of the data frame with the shape attribute. You can see that we got dimensions as integer values. After this, list the data type of each column, number of non-missing values, and memory usage with the info method, which is the primary method to get the most metadata at once. For all data frames, columns values are always one data type. The same holds for relational databases. Data frames as a whole might be composed of columns with different data types. Then get the summary statistics for the numerical columns and transpose the data frame for more readable output with this line of code. Here, the powerful describe method produces different output based on the data types provided in the include parameter. By default, describe outputs a summary for all the numeric, mostly continuous columns and silently drops any categorical columns. You may use np.number or the string number to include both integers and floats in the summary. Let's run this line of code. Technically, the data types are part of a hierarchy where number resides above integers and floats. Take a look at this diagram to understand the Numpy data type hierarchy better. Broadly speaking, we can classify data as being either continuous or categorical. Continuous data is always numeric and can usually take on an infinite number of possibilities such as height, weight, and salary. Categorical data represents discrete values that take on a finite number of possibilities such as ethnicity, employment status, and car color. Categorical data can be represented numerically or with characters. Now let's get summary statistics for the object and categorical columns. Categorical columns are usually going to be either of type np.object or pd.categorical. When you run this line of code, you find that the output data frame is transposed with the t attribute. This eases readability for data frames with many columns. It is possible to specify the exact quantiles returned from the describe method when used with numeric columns. Here's the code you can use to achieve this. We now have the exact quantiles in the output. Great! In this video, we learned to develop a data analysis routine.